Everybody. Welcome back. Okay. It was a lovely session last time, and I think we are going to go ahead full throttle for the next topic, that is combination. Okay. And I know there is a slight mistake in calculation of the last sum in progression, which I will be doing. So don't worry about that. Okay. Now let me check. Om, thank you for the very good namaste. Rahul, my name is Rashmi Lonikar. Then Jignesh, good afternoon. And whatever questions you have taken, let us complete the chapter, and then any questions that you want will be taken up. Okay. Harshita, Venkat Lakshmi, Sia, Priyesh, uh, then Mohammed, Shweta, Amit, Komalpreet, Sneha, Abhishek, Manish, Ananta, Kaushal, Prakriti, Tamanna, Pranathi, Jannavi, Yamini, Vidushi, Pranathi, Dhruv, then Apurva, Pratyush, then Shalini, Krishna Anandan, Manisha, yes, Suprava. Thank you, Suprava. You like the class and your doubts get cleared. That's very nice. Thank you for the feedback. Chaitanya, Ashish, Piyush Gupta, Nishigarg, Aditi. Yes, Aditi, I'll take up that question also. Parth, Vidisha, Asha, Saloni, Roshni, Deepika, Gautam, Mansi, Mrunalika, Asmita, Sakshi, Sulakshana, Akshata, Reet, Dikshika, Arit, Varun, Amar, Tanvi, Vani, Kavitha, Chavi, Nandini, Anshika, Aisha, and Gangamma. Okay. A very good afternoon to, yes, Anshika, yes. Okay, Gauri, Dev, Bhumi. Okay, excellent. So now let us dive into the class. Last time I told you the difference between permutation and combination. Okay, where the order is important when we say it's a permutation, and when the order is not important, then we say that it is a combination. Okay. So we are concentrating on combination today. And before we proceed further, let us understand this. Let me revise this concept of factorial. Okay, if somebody missed out the class last time, so you could like understand it now. Okay, so what does factorial mean? Factorial means you take from 1, you take up to that number. So 2, 3, up to where? N minus 2 into n minus 1 into n. Okay. So keeping this in mind, suppose I have 5 factorial. So what is 5 factorial equal to? 5 factorial is, can anybody tell the value? It's already written over there, but 1 into 2 into 3 into 4 into 5. Okay. 1 2s are 2, 2 3s are 6, 6 4s are 24, 24 5s are 120. Okay, this is the way you have to do it. So as I told you, try to remember these first three, like, because 2 factorial is equal to 2, then 3 factorial is 6, 4 factorial is 24, 5 factorial is 120, and 6 factorial is 720. Okay. So if you can remember up till here, that's more than enough. Then you can using this. So suppose somebody asks me 7 factorial, I can always do on the calculator, but I don't have time. So anything that is already there in my head, it becomes easier for me to use. Okay, so 7 factorial will be what? 7 into 6 factorial. So because I already know 6 factorial is how much? 720. So 7 into 720, that much only I have to do on the calculator and I get 5040. Okay. So if I know up till here, I can easily do it. So that was about the factorial. Then there are two very important rules. There are three important rules rather. The multiplication rule, the addition rule, and the golden rule of factorials and formula. Okay. That if whenever you are in doubt, what you should do is you should expand. Okay. That way you will never get any difficulty in either permutation or combination. So first the multiplication rule says that if I'm able to do one thing in m different ways, and after that work is done, I do the second work in n different ways, then the total number of ways in which both these jobs, that is A first job and the second job, can be done is in m into n ways. Okay. So that, for example, we're taking that if one can go to school by 5 different buses and comes back by 4 different buses, then the total ways in which I can go to the school and come back is 5 into 4, that is 20. The second extremely important rule is the addition rule, that which says that if one job can be done in m ways and an alternative job can be done in n ways than either of the two jobs, because the same jobs I will not do with by two different methods. I have two different methods in one job, so I can do it in one way or the other way. Then the two jobs can be done in m plus n different ways. Okay. So, like if I want to go to the school, I have an option of bus or an auto. So I can't go on both, right? I can't go on a bus as well as an auto. So I have to choose between a bus and an auto. In that case, what do? I add. Okay, so this addition is there. And so if you remember this, then half the problems will be sorted out. And means you have to multiply, and or means you have to add. Okay. So we are talking about combinations now. Yes, Vikash, Mahak, Neha. Yes, Tisha. Yes, Janvi, I'm revising, right? Sandhya. Yes, Priyesh, yes. Excellent. All of you have given me the answers. Yes. Yes, there you can join the lecture on the PC also, provided your PC has a um, speaker so that you will be able to hear also. Priyesh, I'll come back to your question. Okay. Yes, Kushal, thank you. Okay. So the number of ways in which smaller or equal number of things are arranged. So, Priyesh, something like what you are saying, let us think. See, what happens is that there are n different ways, and then we are choosing with r. Okay. So, n is always greater than or equal to r. Suppose I have 10 chocolates. I can choose one chocolate, two chocolate, three chocolate, or maximum 10 chocolate, right? I cannot exceed 10. So my R will always be less than or maximum equal to N. So that is a very important concept in permutation and combination. Also, the second important concept is that both N and R can never be negative. Okay, N and R can be 0 or positive. Okay, so if n is 0, it does not mean anything, because then I don't have anything. Suppose I want to eat a chocolate and if there is no chocolate there, then the question will not arise. Okay, so r can be 0 if there are 10 chocolates and I don't want to eat any of them, which is very strange. I will always want to eat a chocolate, but if there are 10 chocolates kept in front of me and I say nahi main nahi khaungi, so that means what? That means R is 0. So R can have the values. Okay. So R will always lie between 0 and N. Okay. So R will lie between 0 and N, and they will always be integers. Okay, the number will always be integer. So r will always be a positive number or a 0. Then r will cannot be a negative number. R cannot be a fraction. Okay, so these are the very important things that you should know. Okay, what does combination say? The number of ways in which smaller or equal number of things are arranged or selected from a collection of things where the order of the selection is not important. Okay, is not important, are called as combinations. Okay, so what is the formula? NCR is equal to n factorial upon r factorial into n minus r factorial. Okay, now can you see this sounds familiar? N factorial upon n minus r factorial, right? This sounds familiar. That is because this is equal to NPR upon R factorial. Okay, so NCR is NPR upon R factorial. So either of these you will need to use. And the symbols are also explained. You can write it as NCR, then you can write it as NCR, or you can write it as CNR. Okay, so no problem. These are very important that you should understand that NC0 is always equal to 1. NC1 n is always equal to 1. NCR n minus r is equal to NCR. These are complementary combinations. Okay, these are called as complementary combinations. Means what? If I have phi C3, this will be equal to phi C2. Okay, I will show you. I will show a solved example, and from there we'll be able to understand. And then this is also a very important. N plus 1 sorry, not n. N plus 1 CR is equal to NCR plus NCR minus 1. Okay. Now let us see. First thing, let us see. Let us see first 5C0. What does the formula say? NCR is equal to n factorial upon r factorial into n minus r factorial. Okay. So what is n here? N is equal to 5. What is r? R is equal to 0. So this will be equal to 5 factorial upon 0 factorial into 5 minus 0 factorial. 5 factorial, I write as it is. Remember, last time I've told you that 0 factorial is always equal to 1. So 1 into 5 minus 0 is 5. So will be 5 factorial. So 5 factorial will get cancelled. Answer will be equal to 1. So we have talked about the first one. Now let us talk about the second one, second formula. Why I am showing you all this is because sometimes in the exam you get panicked and you don't remember the formula. No, don't worry. You can always solve it. You will still get the answer. Only you may require 5-10 seconds more. So don't worry. If you are not at the end of the day, if you feel you are not able to like remember or first learn all these formula and then recollect those formula, don't worry. You can always solve it. Okay, so let us go to the second sum. Second sum is 5C5. Okay, NCN. We are doing this. 5C5 will be equal to 5 factorial upon 5 factorial into 5 minus 5 factorial. Okay, R is how much? R is also 5, N is also 5. So this is equal to 5 factorial upon 5 factorial. 5 minus 5 is 0. So 0 factorial is 1. So 5 factorial will get cancelled and you will get answer as 1. Okay. So understood the second also. Let us go to the third one. They are saying these are complementary combinations. NC n minus R is equal to NCR. So if I have pi C3, its complementary combination will be what? Pi C2. Okay, because 5 minus 3 is 2. So phi C3 should be equal to phi C2 according to the formula. Let us check. Okay, so phi C3 is equal to 5 factorial upon 3 factorial into 2 factorial. 5 minus 3 is 2 factorial, which is equal to 4 into 5 upon 2, which is equal to, because 3 factorial will get cancelled, upon 2 is equal to 10. Okay. Now let us see phi C2. Phi C2 is 5 factorial upon 2 factorial into 5 minus 2 is 3 factorial. Okay, so this is equal to 4 into 5 upon 2, which is equal to 10. So this is also proved that NC n minus R is equal to NCR. Now let us see this one. Okay, this was the third one. Let us consider the fourth one. Fourth one says what? N plus 1 CR. Suppose I have phi C3. Okay, suppose I have phi C3. So what does it mean? It means that n plus 1 is equal to 5. Okay, because I'm doing the fourth one. R is equal to 3. So pi C3. Now if n plus 1 is 5, n is equal to how much? N plus 1 is 5, n will be n 5 minus 1, which is equal to 4. So pi C3 will be equal to 4C3 plus 4C3 minus 1. Okay, so pi C3 is equal to 4C3 plus 4C2. Okay. How much is this? 4 factorial upon 3 factorial into 1 factorial plus 4 factorial upon 2 factorial into 2 factorial. So this will be 4 plus 6, which is also equal to 10. Okay, so you can see here that pi C3, which we had calculated over here, this is also equal to 10. Okay, which is equal to pi C3, which is equal to 10. And here also I've got the answer as 10, pi C3. So sometimes in some problems, you may need this type of working. So that is why you should know this formula. Okay. And always remember that only when you keep doing the sums will you be able to get a good way in which you can do these sums. Okay. Just one time I try and then I say, oh no, it's complicated. That should not happen. Okay. You should be able to do this. Yes, Anshika, very good. Understood? Bhumi, it's always better to join from a PC so that the screen size is big so you are able to see well also and both your hands are free for writing down. Okay. Okay. Please remember that all the sums will not be able to do. So Piyush, please remember that in 2 hours you cannot complete all the exercises. I have given you all the different types of sums which you will be able to do. Yes, Chanchal, don't worry, you will be able to understand. Okay. 4 वाला नहीं समझा, ये वाला. Okay. See, there is another sum with this formula. Once we do that, you will be able to understand. What you have to remember is that you can write the combinations in terms of n plus 1 and n also, and r minus 1 also. Okay. So at this stage, just go with the flow. Just try to get a little idea about what it is, and then we'll be able to do it. Okay. Yes, Mansi? Yes. Yes, everybody, I will be able to do that. Sakshi, in circular permutation, there is not much. You just have to sit around a table and the formula is there. Okay, n minus 1 factorial. So you just have to do it. In case of beads or necklaces, so then you will divide it by half. Okay. Yes, Kripal, I will try to make a video on how to study and pass the exam. Okay, don't worry. Vani, by mostly August, everything gets over. Okay. Now let us concentrate on the sum in hand. Let S be the collection of 8 points in a plane with no 3 points on a straight line. Find the number of triangles that have points of S as vertices. Okay, so what do I have? S is a collection of points. Collection of 8 points. Okay. Now, what do I want? I want to make a triangle. So, how many points are required for a triangle? This is point number 1, P1. This is point number 2. This is P2. And this is point number 3, P3. Okay. So, what should I do? And my formula is NCR is equal to N factorial upon R factorial into N minus R factorial. Okay. Let S be the collection of 8 points in a plane. Find the number of triangles that have points of S as vertices. Okay. So there are 8 points. Okay. So there are 8 points. So N is equal to 8. What is R? R will be the points that are needed to form the triangle. Okay. Last time only I said that, like in combination also we said that how many sequences can we make where each sequence has a particular length. Here, what is the length size? 3 points. Okay, so R is equal to 3. Okay, so number of triangles is equal to 8C3, which is equal to 8 factorial upon R factorial, that is 3 factorial, into 8 minus 3, that is 5 factorial. Okay, so this means how much? This is equal to uh, 8, 7, 6 into 5 factorial upon 3 factorial I know is 6 and 5 factorial I'll remain as it is. Okay. So what will happen now is that this 5 factorial will cancel with this 5 factorial and then you are left with 8 into and then the 6 will also get cancelled and so you are left with 56. So they're using these points, 8 points, where 8 non-collinear points, then you can find form 56 triangles. Okay. So let us go to the next sum. A committee is to be formed out of 3 persons out of 12. Find the number of ways in forming such a committee. Now, is there an order? Okay, you have to just pay attention because sometimes, permutation, combination sums are a little similar, but what you have to see is you have to read what is written. A committee is to be formed of 3 persons. Are they saying that one will be president, one will be this? Nothing. They're just saying that 3 people, there are 12 people whose names have been submitted and they are going to pick up any 3 of them. So in that case, this will be equal to number of ways of forming this committee. Forming the committee is equal to 12C3, which is equal to 12 factorial upon 9 factorial into 3 factorial. 12, 11, 10, 9 factorial upon 9 factorial and 3 factorial is 6. 9 will get cancelled. 6 ones are 6 twos are 220. Let me check the answer. Just a minute. I'm just want to check that the 220 is correct. Yes, no problem. Okay, so that there is no issue. So you have to just pay attention what is given in terms of the wordings. Okay. Now let us go to the next sum. Yeah. See, this is my way of doing it. But if you feel like you can do it more like writing on the line, then do it that way. Tabular form becomes easy when I'm trying to revise. Okay, so that is why we are doing this. A committee of 7 members is to be chosen from 6 chartered accountants. So, okay, so I've written 6 chartered accountants, 4 economists, and 5 cost accountants. So, how many members are needed? 7. In how many ways can this be done if in the committee there must be, okay, now you have to pay attention. There must be at least one member from each group and at least 3 CA. Okay. This at least one means what? It means that your number of members can be 1, 2, 3 up to n. Okay. So 1, 2, 3 up to n. Now let us see. What they are saying, at least 3 chartered accountants. So what can be the possibility? I take 3 chartered accountants, 1 economist, and how many should I form? I should form 7. 3 plus 1, 4, and then I have 3 cost accountants. Okay. Then second possibility, I take 3 CAs, I take 2 economists and 2 cost accountants. Okay, because my total has to be 7. So 3 plus 2, 5, 5 plus 2, 7. Then I can have 3. Then I can have this as 2 and this as. Now we've already done 2. Okay, so this as 3 and this as 1. Okay. So this is 3 and this is 1. Second possibility is what? There are how many? 6 CAs. So I can do what? I can take 4 CAs, 1 economist and 2 cost accountants, 4 CAs. Then I take 2 economics and 4, 6, 1 cost accountant. I cannot have 4 CAs and 4 economists. Why? Because there must be at least one member. Okay, so I cannot forget that also. Then I can have what? Can I have 5? Yes, 5 CAs, 1 economist, and 1 cost accountant. Then makes 7. Okay. Now using this, once my table is ready, how many CAs can I have? 3. Out of how many? 6. Okay, but if I write it like this, I can simply write it as 6C3 into 4C1. This is my N and this is my R. Okay, 4C1 into 3, no, 5, no, not 3. Into 5C1. 3. Okay. So out of 5 cost accountants, 3 have been selected. Now you can solve and do this. Second thing is 3. So out of how many? 6C3 plus into 4C2 into 5C2. Okay. Then I have 6C3, 4C3 and 5C1. Then I have 6C3, 6C4 because now it is 4. 6C4, 4C1 and 5C2. 5C2. Then I have 6C4, 4C2 and 5C1. I will have 6C5, 4C1 and 5C1. Okay. Now I would request all of you to do this calculation at home and then your answer should come to 3570. If it does not come, then we can take it up in the next lecture. Okay. Have you understood how you're supposed to do this? I can understand there will not be a large paper over there, but for practice sake, if you do this once or twice, you will understand it better. Yes, Srishti, all the concepts are clear? Yes, Sarah, as I was saying that you have to keep practicing. Once you start reading the questions, you will be able to identify whether it's a permutation or a combination. And it's okay in the initial time, you may make a mistake for permutation, you may apply a combination formula. That's okay. Once you are practicing, once you revise those questions, you will be able to find out. Yes, Dimolo, I hope I've answered this. Yes, so when I'm from India. Shubhiksha, yes, you understood. Very good. Yes, Ruhani, absolutely clear. Yes, actually, for each of this, you will, like, for example, I'll just show you for the first one. What you will do, this will be 63, so 6 factorial upon 3 factorial into 3 factorial into 4 factorial upon 4 minus 1, that is 3 factorial. So 1 factorial into 3 factorial into 5C3, 5 factorial upon 3 factorial and into 2 factorial. Okay, this is how you're supposed to do them. Okay, and if you're not like this, you're not happy with this, then you can say how many gents are there, how many there? 6 CS, 4 economics and 5 cost. So you have 6 CS, 4 economics and 5 cost accountants. Okay, so what should I do is then I can say that from here I'm selecting 3, then here 1 and then, okay, so 3, then 3, 1. Then you can have 3, 2, 2. Then you can have 3, 1, 3. Okay. So on and so forth. You can keep on doing it. A person has 12 friends, of whom 8 are relatives. In how many ways can he invite 7 guests such that 5 of them are relatives? So there are 12 people, 7 are friends, and 5 are relatives. And how many ways can he invite them such that 5 of them are relatives? Okay, there is no next question. Okay, at least 5, not more than 5, less than 5. No, they're just saying that 5 of them have to be relatives. Okay, so 5 relatives, 8 are relatives. So, okay. Sorry. Okay, a person has 12 friends, 8 of whom are relatives. Okay, 8 are relatives. So for 12 minus 8 is 4. So 4 friends. Now what I have to do is I have to select out of these 8 relatives, I have to select 5 of them as relatives. So that can be done by 8C5. For 4 friends, what do I have to do is that I have to select how many out of 7 people. Out of 7 people, 5 have to be relatives. Okay, so out of that 5 have to be relatives. So that I have already done. So how many people remain? People remain is 7 minus 5, which is equal to 2. So this 2 I have to use from this. So 4C2. Now 4C2 into 8C5 will give me the answer. Okay, is that clear? Yes, it's telling. Very good, very good. Oh, wow. Yes, Harshita, Shweta, Komalpreet. Now let us go to the next sum. Just give me 1 second. Sorry about that. I think something went into my eyes. Okay. In each of the case, find n. Okay, so like we did in permutations also, some questions will be there based on the formula. Some question will be there where simple application of the formula will give you the result. In some cases, you will have to apply something else also. You may have to apply a little bit of algebra, maybe a plus b whole square, those type of formula also you may need. So in this case, what happens is that usually you would need to, but because your exam pattern is MCQ, so I'm trying to show you the shortcut as well as the long cut. You should, like, I always feel that as a teacher, I need to teach you what is perfectly knowledgeable to you. You should be able to gain some knowledge. Passing the exam is one thing, fine, no doubt about that you should be able to pass for you to be able to progress in future. So I will give you the shortcut here, but I will also explain you the method of doing it. So like, for example, if you get this question, in each case find the value of n. Okay, so what is happening here? Suppose for this first question, these options are given. Okay, so 2 or 7, 1 or 6, 2 or minus 7, none of these. So let us see. N 4 into NC2 is equal to N plus 2C3. Okay. Now this can be written as 4 into N factorial upon 2 factorial into N minus 2 factorial on the LHS. okay, on the LHS, which is equal to how much? 4 into n minus 1 into n minus 2 upon 2 into n minus 2 factorial. Okay, n minus 2 factorial. Okay. Now what we will do is, I'm going to cancel this n minus 2, and what will remain is, obviously there are brackets here, n into n minus 1. So this 2 will cancel once and 2 times. And so I'm getting here as 2n into n minus 1. 2n into n minus 1. Now what happens on the RHS? RHS is n plus 2 factorial upon 3 factorial Okay, thank you so much. Okay, so we were talking about n plus 2 factorial upon 3 factorial, n plus 2 minus 3 factorial. And this is equal to n plus 2 into n plus 1 into n minus 1. In the denominator, you will have 6 into 3 factorial is 6 n minus 1 factorial. Okay. So now what happens here is this n plus 1 factorial will cancel with this n plus 1 factorial. So on the RHS, we are left with n plus 2 into n plus 1 into n upon 6. So RHS, LHS is how much? 2n into n minus 1. Okay. So we have 2n into n minus 1 is equal to n plus 2 into n plus 1 into n. Okay, so this n will get cancelled, and what we are left with is 2n minus 1 into equal to n plus 2 into n plus 1. Okay, so you could now solve this because this is a quadratic equation, and then when you solve it, you can get the answer. The shortcut for this is that I substitute these values 2 or 4 and 1 and 6. 4 NC2 is equal to n plus 2 Okay, now what are the options? My options are 2 or 7, 1 or 6. Okay, so let us try to put n is equal to 2. Okay, let n be equal to 2. So 2 or 7 is the first option. So if I put n as 2, so I have 4 into 2c2 is equal to 2 plus 2 is 4, 4c3. Now when I talk of this, it will be 2c2, I know is equal to 1. So 4 on the RHS, and how much is 4c4, which is equal to 4 factorial upon 3 factorial into 4 minus 3 factorial. What is 4 by 3? It is equal to 1. So I 4 factorial upon 3 factorial. So this is equal to 4. Okay, because 4 factorial can be written as 4 into 3 factorial. Okay, so that means n is equal to 2 satisfies the equation. Now let us see if n is equal to 7 satisfies. Okay, but what happens when I put n is equal to 7? Then I have 4 into 7c2 is equal to 4 plus 2, that is 6. Sorry, 7 plus 2, that is 9. Okay, so 9c3. Okay, to 2 or 7. So I've done with 2, now I'm doing with 7. So 4 7c2 is equal to, because this is n plus 2. So this is 7 plus 2, which is equal to 9, and c is equal to 3. Now what will happen over here? What is the value? 4 into 7c2 is 7 factorial upon 2 factorial into 5 factorial. So this is 7 into 6 upon 2 into, okay, so this, how much is this? 2 2s are 2 1s are 2 2s are. So 14, 14, 6 are, which is equal to 14 into 6, which is equal to 84. Now let us see 9c3, 9c3, which is equal to 9 factorial upon 6 factorial into 3 factorial. So that is equal to 789 upon 6. Okay. So 6 will be 3 3s are and 3 2s are. So which is equal to 5 is equal to 6 into 7. Okay. So here we'll be able to see that both these are satisfying the value. Okay. Right. So you can put the values also and you can see. So there also you get also. Okay. 7, 12 sevens are 84. Okay. So both you are getting as 84. So what happens here is, in the exam, you can just choose this option, 2 or 7. That is the correct option. But always remember, sometimes they may put only one value. And whether that value is correct or not, you have to see. Okay. You may usually when you are having quadratic, in quadratic you will get two values. But what happens if one is positive and one is negative? Obviously, the negative cannot be considered in permutation combination. So that value, even though it's a valid value mathematically, it goes out of the window in statistics. Okay. So this is the way you should be able to do it. So either you do the whole thing, you do the cutting, and then you can get an answer which is perfectly all right, or you can see the options and do it. Okay, let us see the second option and let us try to do it. N plus 2 Cn is equal to 45. N plus 2 Cn is equal to 45. Now they've given minus 11 or 8, 8, 11 or 11 or D. Now here itself you can see this option is not going to be considered because 11 has a minus sign. This also will not be considered because D has a minus sign. Okay, now we are left with, there is a single 8 or 11. So we will have to, in this equation, n plus 2 C n is equal to 45. n plus 2. Is equal to 45. So what is the values? 8 or 11. Okay, I have to check. Now, if I put 8, what will it be? 8 plus 2 is 10. 10 C 8 is equal to how much? Okay, so this is equal to 10 into 9. Oh, is it? Okay, yes, let me see. Okay, एक minute. Okay. Yes, there is something, I think, because of the rains, there is some issue. Please excuse. So, what we are trying to do is we're trying to put 8 or 11 in the option and let us see. So, what is the question? N plus 2Cn is equal to 45. And so, what I have done, I've tried to put n as 8 and c. So, n plus 2, that is 8 plus 2 is 10, C8 is equal to 10 into 9 upon 8 factorial into 2 factorial into 8 factorial. Okay, so this 8 factorial gets cancelled. 2 will get cancelled with this as 5 and you get as 45, which is the RHS they have already given. Now let us check for 11, okay, because there are two options. But usually if I get the answer here, that is more than enough. But for you to practice, you should always put in all the 4 values and 4 option values and check, because that will give you more practice. If I put 11, so this will be 11 plus 2, that is 13. 13 C 11. So how much is this? This is equal to 13 into 12 into 11 factorial upon 11 factorial into 11 minus 13 minus 11, which is equal to 2 factorial. Okay, so this 11 factorial gets cancelled and you are left with this is 6, so that is 13 into 6. Okay, which is obviously not equal to 45. Okay, so there are these two methods. Golden rule: if I'm in doubt, I will write the whole thing down and I will expand. I will get the same perfect answer. Okay, so here using the expansion methods, like here we have done. So here this method is the expansion method, and here I just have to solve this. So this is how much? 2n minus 2, which is equal to n square plus n plus 2n plus 2. Okay, so this is equal to n square plus 3n plus 2. And I take this also to this side, this becomes minus 2n plus 2, which is equal to n square plus 3n minus 2n gives you plus n plus 2 gives you plus 4. Okay. So you can have this and then you can solve this and you can get the answer also. Okay, so you could do that and you can get the answer. So let us now move to the next one. Let me just check. Yes, Komalpreet, correct. 2 or 7. Nishi, where did I forget the 6? No, I did not forget the 6. I cancelled this 6. Okay, this 6 factorial. This 6 factorial 6. Okay, let me show this. 9. Take a blue pen. Okay, I just, because of lack of space, I did it. 9C3 is equal to C. What is the answer? 9 factorial upon 9 minus 3 is 6 factorial into 3 factorial. Okay, pay attention, Sakshi. Okay, here 9 factorial, 6 factorial into 3 factorial. That is the formula of combination I've used. Now 9 up to 6 I'm going to write down. So this is equal to 9 into 8 into 7 into 6 factorial upon this 6 factorial into 3 factorial. Okay. Now this 6 factorial will get cancelled. This 6 factorial will get cancelled. Now how much is 3 factorial? 3 factorial is 6. Okay. 3 factorial is 6. So then I'm left with 9 into 8 into 7 upon 6. Now 6 directly will not cancel. So 3 2s are 3 3s are 2 1s are 2 4s are. And so I get this 84. Okay, is that clear to everybody? I hope everything is clear. Yes. Which sum are you talking about? 63. We just write the question number also. Okay. Yes, Komalpreet, that is the very thing I'm trying to tell you, that you cannot have a minus 11 or 8. Even though when you solve the quadratic, you will get 11 and 8, but minus 11 and 8, but because n cannot be a negative number, and that is why it is not considered, and we consider only 8 in that option. Okay, so minus 11 will not be considered. Yes, understood? Yes, Sandhya is understood. Yes, Asha. Yes, Mohammed will take a break. No doubt about that. Yeah. Ruhani, Vani. Yeah. So just make sure that, like, for this, like I'm trying to just show you here. This is 4 n C2 is equal to n plus 2 C3. I'm considering only the LHS. 4 into, so this is 4 multiplied by n factorial upon n, that is 2 factorial into n minus 2 factorial. Okay, this is the case. Now n, I'm going to write from n up to n minus 2, because otherwise I won't be able to calculate. 4 into n minus 1 upon 2 factorial is 2 into n minus 1 factorial. Okay. So what I do is, what do I cancel? N minus 1 factorial. See, the factorial term is gone out. So it becomes easier for me to solve. Now what is left on the LHS is, and these two ones are 2 twos are. So what is left here is okay. Okay. This is n into n minus 1 into n minus 2 factorial. Okay, so this is also 2 factorial. So this gets cancelled. Okay, n minus 2 factorial gets cancelled and we are left with 2 into n minus 1 on the LHS. So what is LHS? 2 into n minus 1. Now let us consider the RHS. Okay, let us consider the RHS. What is the RHS say? It is n plus 2C3. N plus 2C3 is equal to how much? N plus 2 factorial upon 3 factorial upon n plus 2 minus 3 factorial. Okay, n plus 2 minus 3 factorial. Which is how much? This is n plus 2 factorial upon 3 factorial, I know is 6. And how much will this be? N plus 2 minus 3, it will be n minus 1 because plus 2 minus 3 is minus 1 factorial. Now, I have to take n plus 2 from n plus 2 up to n minus 1. So, this is equal to n plus 2 into n plus 1 into n minus 1 factorial. Okay? Upon 6 into n minus 1 factorial. Okay. Now I cancel this n minus 1 factorial. The factorial terms go out and on my RHS I have n into n plus 1 into n plus 2. Okay. I have, so here what happens is I have 2n into n plus 1 is equal to n into n plus 1 into n plus 2. Now this n will again get cancelled. This n will get cancelled with this n and I'm left with 2n plus 2 because I expand this bracket 2n plus 2 which is equal to how much is this? N square plus n plus 2n plus 2. Okay. And then I have to solve this. Is that clear? Upon 6 and this upon 6. So what is the main focus is that you understand how to solve it. And because it is an MCQ exam is that you are going to do this by the method of say, putting the options and doing it. Okay. Yes. Let me check. Yes. Okay. Can we take a break now? Yes, yes, 5 minutes maximum. Yes. Thank you. Welcome back. Yes. Dipanshu, ठीक है. Utkarsh, yes. Utkarsh, in where in exercise 5A, question 5 indicates that n could be negative? No, it should not be the case. Okay. Let me see. Yes, Gautam, very nice. Yes, it is n minus 1. Yes, sure. Yes. Pankti, correct. Yes, all of you who want any particular sum to be solved, please write it down over there in the chat box, and then we will take them one by one. Okay, now let us go to the next sum. The next sum is using the formula, using the relation that NCR is equal to NPR upon R factorial. Okay, now NCR is given to you, that is 10CR is how much? 120. And this 120 will be equal to 10 PR upon R factorial, right? I'm just using this formula. 10 CR, which is given to me as 120, is equal to 10 PR upon R factorial. Now 10 PR is already given to me. So 120 is equal to 604 800 upon R factorial. Okay. That means R factorial. I cross multiply. Take this R factorial on the LHS and bring 120 onto the RHS. So this is 604 800 upon 120. That means R factorial is how much? 604 800. 604 800 divided by 120 is 5040. Okay. So I get this as 5040. Means what? I must find a number whose factorial is 5040. Now, let us go to the thing that I have already talked to you. You know, one way to do this is that every number you start on the calculator 1 into 2 into 3. You could keep doing that, or you could, like, I can show you over here. Can you see the calculator? Just put it in the chat box. Yes, Mrinalika Asha, can you see the calculator on the screen? Okay, so I could do 1 into 2 into 3 into 4 into 5 into 6 into 7 into, see, I got into 7 is, I get 5040. So 7 R factorial is 7 factorial, which is equal to 5040. So on the calculator also you should do this. So means what? R is equal to 7. Okay, you can't see the calculator? Okay, let me show you over here. Now remember, do you remember that 5 factorial is 120? Okay, all of you remember that? Now, what will be 6 factorial? 6 factorial will be 6 into 5 factorial, which is equal to 6 into 120, which is equal to 720. Right? Now, what will be 7 factorial? 7 factorial will be 7 into 6 factorial. How much is 6 factorial? 720. So 7 into 720. Now 7 into 720 is 5040. And so therefore R is equal to 7. Is that clear now? Yes? Yes, Tamanna, yes. it's okay, Apurva, you couldn't see that, Shama. But now I have shown, that is why I have written it down and shown it to you. Or else on the calculator also, if you keep doing 1 into 2 into 3, when you after you type 7, you will get 5040. Okay? Yes. Is this clear? This question relies on you unknowing this formula, which is the most important link between permutation and combination. Okay? Yes? Put it in the chat box if you have understood this. Yes, Asha, Vidushi, Utkarsh, understood? Excellent. Now let us see. Yes, Om has already solved it. Yes, Om. Now, find R if 18CR is equal to 18CR plus 1. So all those who were having difficulty in understanding the third formula and the fourth formula, now these two simultaneous sums will give you a fair idea about what is to be done. Okay. Now, if 18CR is equal to 18CR plus 2. Okay. Now, what is the formula? NCR is equal to NCN minus R. This is a very important formula in combinations. Okay, NCR is equal to NCN minus R. Now, let us see. So, 18CR will be equal to how much using this formula? 18C, 18 minus R. Okay, 18CR is equal to 18C, 18 minus R, which is also equal to 18C R plus 2. Okay, this is given. This is my given. Here, this part I am using the formula. Okay, and this part I am using the given in the question. So 18CR is 18C, 18 minus R is according to the formula NCR is equal to NC N minus R. What about 18C, 18 minus R is equal to 18C R plus 2, that is from the given condition. So that means equating, we get 18 minus R is equal to R plus 2. 18 minus R. So this I am equating with this because 18 is already there and this I am equating. Now taking R to one side and numbers to the other. This plus 2 becomes minus 2 and this minus R becomes plus R. So R plus R is equal to 18 minus 2. So 2R is equal to 16. R is equal to 8. Okay. Has everybody got this answer? Just check. Yes. Very good. Tamanna, Saloni, Sandhya, Komalpreet. Clear? Vidushi, clear? Yes. Crystal clear. Yes, Om. I missed your crystal clear. This is from the solved example, Utkarsh, from the study material that is available. Yes. Prayukta, Vani, yes. Apurva, yes. Srishti, yes. Mansi, yes. Asha, yes. Vidisha also has got the correct answer. Yes. Excellent that all of you are taking the effort and solving it on your own. Very good. Now, this you should the questions on balls you should practice because even in probability you will have questions on them. So at least the solving part about how many balls to select, how to select, those type of concepts you get cleared in permutation combination, so that when you're doing your probability, you will only have to worry about the probability aspect of it. Now, a box contains 7 red, 6 white, and 4 blue balls. How many selections of 3 balls can be made so that all 3 are red, none is red, and one of each color? A box contains 7 red balls. Okay, so 7 are red, 6 are white, and 4 are blue. First option, all 3 are red. All 3 are red means what? Can I select a red ball from a white ball? No. Can I select a red ball from a blue ball? No. I have to select a red ball from the available red balls only. How many red balls are available? 7. So, and how many do I need? 3. So, I have n as 7. There are 7 red balls. Out of this 7, I have to select 3 red balls. So, 7C3. So 7 3C will be 7 factorial upon 3 factorial into 7 minus 3, that is 4 factorial, which is equal to 7 into 6 into 5 into 4 factorial upon 3 factorial into 4 factorial. Okay. So this 4 factorial gets cancelled. This 6 gets cancelled because 3 factorial is 6. So you are left with 35. Okay. So have you understood part A? That I need all the 3 balls to be red. So I must choose them from the available red balls. Now let us see the B part. None is red. None is red means what? What does it imply? Ball may be white or blue. Okay. Ball may be white or blue. How many white balls are there? 6 white plus 4 blue, which is equal to 10 balls. Okay. Means what? Out of this 10 ball, how many balls have I to select? 3 balls. So this is equal to 10C3, which is equal to 10 factorial upon 7 factorial into 3 factorial, which is equal to 7 into 9 into 8 into 7 factorial upon 7 factorial into 3 factorial. So this 7 factorial will get cancelled and 6 factorial, 3, this will give you 3 and this will give you 4. So 3 into 4, 12, 12 into this is 120. Okay. Now, the C part. One of each color. One of each color. Means what? Out of 7 red balls, I select 1 red. So similarly, out of 6 white balls, I select 1 white. And out of the 4 blue balls, I select 1 blue. Okay. So what will this be? This will be 7C1 into 6C1 into 4C1. Okay. Which will give you 7 into 6 into 4. Okay, so 7C1 will be 7 factorial upon 1 factorial into 6 factorial. So the 6 factorial can get cancelled. So NC1 is equal to N. I will show you the formula. NCN is equal to 1. NC0 is equal. Okay, we have not written NC1. Doesn't matter. NC1 is equal to N. Okay. So you get this. Seven into 6 into 4, 35. Seven into 6 into 4. 7 into 6 into 4. 168. Is that clear? Crystal clear? Yes, Nandini? Anantan? Yes, Komalpreet, 168 ways. Manisha, why did I cut 8 in the B option? Where did I cut? Okay, that is because you have this as 3 factorial. Okay. If you're not comfortable, this is what I just skipped a step here. This is 10 into 9 into 8 into 7 factorial upon 7 factorial into 3 factorial. How much is 3 factorial? That is 6. Now this 7 factorial gets cancelled. This 7 factorial gets cancelled. And for 6, I have this. I could do that 720. This is equal to 720 upon 6, which is equal to 120. Okay. If you're not comfortable with cancellation, you could solve the numerator and solve the denominator on the calculator and be able to do it. Okay. No worries at all. Okay, Nishi, we'll see that also, okay? Yes, Vani, Mrunalika, Sandhya, Vidisha, Anshika, Vidusha, Yash. See, even NCA is equal to NCB, Yash, it means either you have A is equal to B or it can be A is equal to N minus B, okay? You have this NCR is equal to NCN minus R. So either I can have this I can have both to be equal to R or I can have R to be equal to N minus R. Hope it solves it. Yes. Yes, Vani. Yes, Utkarsh, N could be an integer and it can only be a positive integer. Okay. And now let me use the golden rule to solve this sum. Where we do the actual this thing, but usually in the exam you can simply use the option and solve it. But I want you to I want to show you and I want you to be confident when especially when we are doing any probability sums, because there the option will not be directly for the combination or permutation. Okay, that is why I keep pushing. Like some students may say that why do we have to do this, because the answers are already there, I just have to substitute. Fine. What happens when you do try to solve probability sums? Then you get stuck. So instead of that, it is better that you know the method. Okay, now we have 28C2R is equal to how much? Let me first simplify this part, which is equal to 28 factorial upon 2R factorial upon 28 minus 2R factorial. Okay. Now, what is this upon 24 C 2R minus 4, which is equal to 24 factorial upon 24 minus 2R plus 4R, 4 plus 4 into 2r minus 4 factorial. Okay. So this is the case. Now this upon this is equal to this much. And how much is this? 24 plus 4, that is equal to 28. So this is 24 factorial upon 28 minus 2r factorial into 2r minus 4 factorial. Is that clear? Now I have to divide them because there is this sign, so I have to be careful. So this upon this. So I have, when anything is there in the denominator, you just have to flip. So I have 28 factorial upon 2r factorial into 28 minus 2r factorial is upon, that is into 28 minus 2r factorial upon 2r minus 4 factorial upon 24 factorial. Okay. Now what is this? Let us see. Now this 24 and 28. So this will be equal to 28 into 27 into 26 into 25. And 24 factorial will get cancelled. Okay. Another thing that is getting cancelled is 28 minus 2r and 28 minus 2r factorial. Okay, both these factorial get cancelled into, now I have 2r and this is 2r minus 4. So I will write up to this. So this is 2r into 2r minus 1 into 2r minus 2 into 2r minus 3. And 2r minus 4 factorial will get cancelled. Okay. So this is equal to how much? 225 is to 11. This is equal to 225 is to 11. So I could do this, that I can now take this into the side, cross multiply and get 2r into 2r minus 1 into 2r minus 2 into 2r minus 3 is equal to how much? This into 11 upon 225. Okay, so how much is that? Can anybody tell me what is the value? Yes, anybody can give me the answer. How much is this? Which is equal to 28 into 27 into 26 into 25 into 11 upon 225. How much is this? Is anybody? 491400. Okay, which is equal to 491400. So I have to now, like in the last time also we have done, these numbers are consecutive. 1, 2, 3, 4. That is 2r, 2r minus 1, 2r minus 2, 2r minus 3 is equal to this thing. Okay. And so let us see 491400. So I have to just find the factors. So let me put r, because the options will be given. R is equal to 14. Let us see what happens if I put r is equal to 14 in this equation. What will I get? What will I get? I will get you're not able to see the calculator, na? 28 into 27 into 26 into 25. 28, 20, 27, 26, 25. Yes. Okay. So if I put R is equal to 14, this will become 28. 2R, this we are talking about this equation, 28 into 27 into 26 into 25, which is equal to 49140. Okay. So in case you're not able to recollect anything, in case you're not able to substitute and get the answer, the final way of doing things works excellently. So don't worry about it. You will be able to do it. Okay, so now you have 2R is equal to this thing. So okay, so we have now got 2R is equal to 14, so R will be equal to 7. Okay, so therefore R will be equal to 7. So once we have put this, you've got this value, and we'll get R. This is actually 2R is equal to 7. Ravni, you want me to explain? Okay, just let me just show it to you again. Yeah. Why is there some confusion? Let us check. Okay. Now 28C2R is to 24C2R minus 4. Okay. This is the question. So I solve 28C2R, which is equal to 28 factorial upon 2 factorial into 28 minus 2R factorial. Okay. This is okay. 24C 2R minus 4 is 24 factorial upon 24 minus 2R, and minus into minus becomes plus. So you have this plus 4. This plus is very important. Okay, this plus sign. This plus sign is very important. Otherwise, this question would have become a nightmare to solve. Now this becomes what? 24 plus 4. That becomes 28 minus 2R. And this becomes 2R minus 4. Okay. So till here, anybody has any doubt? Yes, Shravani. Okay. Now somebody is saying this figure is incorrect. Okay, let me check. I will do the calculation myself now. Okay, so now what happens is 28C2R value is this much. This is 28 factorial upon 2r factorial into 28 minus 2r factorial into this becomes this denominator flips. So it becomes 28 minus 2r factorial into 2r minus 4 factorial upon 24 factorial. Okay. So now what happens is till 24 factorial I write and then 24 factorial gets cancelled out. So 28 into 27 into 26 into 25 upon this becomes 2r to 2r minus 4. 2r into 2r minus 1 into 2r minus 2 into 2r minus 3. So I get which is equal to 221 upon 11. Okay. 221 upon 11. Now there is some confusion. So let me do the calculation myself and let me write it down. Means what? Okay, just let me do that. So let us not keep any type of confusion in our mind. Okay, we have this. Now let us cross multiply. So we have 2r into 2r minus 1 into 2r minus 2 into 2r minus 3 to be equal to 28 into 27 into 26 into 25 into 11 upon 225. Okay. Which is equal to. Now let me see myself. It's 26, 28 into 26. 28 into 27 into 26 into 25 into 11 gives me 5405 400. Okay, just let me write it down. 5405 400 upon 225. Is that correct now? Divided by 225. You get 24024. 24024. Now I must find the factors of 24024 such that they are a multiplication of 4 consecutive numbers. Okay. So what we have done here is that the options will be given. So I just have to put in the options and see. Okay. Or you can do it by trial and error method also. Okay. So now let us put R is equal to 7 and see how much I get. This becomes here. I'm putting R is equal to 7 over here. It becomes 2R is 14. 2R minus 1 is 13 into 12 into 11. Now let us see how much is this. 14 into 13 into 12 into 11. 24024. Okay, which is equal to 24024. Yes, all doubts cleared. Okay. Yes, Manisha, that's correct. 67 is correct. Nishi, right. Ravni, now I hope you've understood. See, everyone was giving the right answer, but you what was happening is where I want that answer was not there. Okay. So now, yes, Janvi, noted. Hmm? Okay. Now let us go to the next sum. I hope everybody's doubt is cleared for this this example. Okay, no problem. Find x if 12c5 plus 2 into 12c4. Okay, yes, this is the very good example of, yeah, just mark the sum as important so that at least once a month, once a week, you should practice this sum. Find x if 12c5 plus 2 into 12c4 plus 12c3 is equal to 14cx. You have to find the value of x. Now remember, like we have the algebraic equations. So this is similar to that. Okay. So the format is similar. But what are we going to do? Use here n plus 1 Cn is equal to NCR plus NCNR minus 1 and NCN minus R is equal to NCR. The only thing here is that this formula we are going to use like this. This side we are going to use, and for this we are going to write it like this. We will not have n plus 1 Cn is equal to this. We are going to use NCR plus NCR minus 1 to be equal to that. Okay. So very important step here is expand this. Expand this. Okay. Now what I have to do is I have to expand this. So let us see how I'm supposed to write. Means what? I will write this as 12c5 plus 12c4 plus 12c4 plus 12c3. Instead of 2 into 12c4, that is, I have two 12c4s, I'm writing them separately. 12c4 plus 12c4. What is it? It is equal to 2 12c4. But here I am written them this way. Why have I written them? Because I want to club. Okay, because I want to club. So I'm going to use this and I'm going to club this. Now when I'm clubbing this, what will this be equal to? NCR plus NCR minus 1. This is 5, this is 4. R is 5, R minus 1 will be 4. So this is true. This is n, this is n, this is also n, and this is also n. So same. So I have to first verify whether I can use that formula. Okay, you don't use it just because I am saying it, but you have to start using your own logic. So here, yes, this is a very typical sum. There, this expansion is the most critical part, and so we are doing it. So 12c5 plus 12c4. What is this equal to? N plus 1 Cn. What will be n plus 1? The n is 12 here, so n plus 1 will be 13. So this will become, very importantly, this will become 13c. This is R. Okay, this is R. 13c5. Okay. N plus 1 CR is equal to NCR plus NCR minus 1. So this will become 13c5. And what will this become? Here R is 4 and this becomes 12. So 12 plus 1. So plus 13c4. Okay. Now 13c5 plus 13c4. Again, I'm going to use this formula. Okay. Again, I'm going to use the formula. So once I've used it here, once I've used it here, now again, I'm going to use the formula here. So 12c5 plus 12c4 is 13c5 plus 13c4 is equal to what? N plus 1 CR. What is R? R is 5. What is N plus 1? 13 plus 1. So it will become 14c. Okay, so 14c5 is equal to 14cx. Okay, from RHS. This is my RHS. From RHS, I have 14c5 is equal to 14cx. Okay, so that means what? X is equal to 5 because I'm equating 14c5 is equal to 14cx. So x is equal to 5. But, okay, important. Remember that x is not only equal to 5. What we have to see is We have to remember that NCR is equal to NCN minus R. Okay, now how much is R here? 5. How much is X? X is 14. Okay, so 14C5 will be equal to 14C 14 minus 5, which is equal to 14C9. So the value of X R can be equal to 5 or 9. R will be equal to 5 or 9. So or you can say X. X is equal to 5 or 9. Okay, so just remember this is a very critical example. Once you do this example, you remember always that of the property that NCR is equal to NCN minus R. Yes, thank you, Dhruv. Thank you, Nishi. Yes, Yash. Yes, all clear, Vidushi? Yes, Manshi. Mansi. Asha. Anshika is crystal clear. Yes, Komal. That you have to have 9 as well as 5. Yes, Anand, 9 and 5. Saloni, yes, correct. Absolutely. Janani, yes. X is 5 and X is 9. Now, this is also a very important formula. And here, remember, this we have just now done. N plus 1 CR is equal to NCR plus NCR minus 1. And NPR is equal to N minus 1 PR plus R into. This R is very important. Okay. Plus R into N minus 1 PR minus 1. Okay. Some important formula: when n1 are numbers of exactly alike things, when n2 are number of exactly alike things, when n3 are number of exactly alike things, and the rest of the n things are different, then we are using this formula: P is equal to n factorial upon n1 factorial into n2 factorial into n3 factorial. That is, like, you have maybe different fruits are there, or maybe different balls are there. So in that case also, this can be used very well, this formula, that the number of ways in which these n things can be arranged is given by n factorial upon n1 factorial, n2 factorial, n3 factorial. Now, how many different, using that formula, let us try to find out how many different permutations are possible for the letter calculus. So let us see. C is repeated 2 times. A is repeated once. L is repeated 2 times. U is repeated 2 times. S is 1 time. 1, 2, 3, 4, 5, 6, 7, 8. 2, 4, 6, 8. Okay, I have considered all. So what is happening is, what is the formula? Different permutations. Different permutations is given by n factorial upon n1 factorial into n2 factorial into n3 factorial. Okay. Now what is n? N is 6, 2, 4, 6, 8. Okay. 1, 2, 3, 4, 5, 6, 7, 8. Now n is 8. So that is 8 factorial upon n1, n2, n3, so on. So this is 2 factorial into 1 factorial into 2 factorial into 2 factorial into 1 factorial. So, which is giving me how much? 4 and 8. 2, 4, 8. How much is that? Can anybody tell me the value? 8 factorial upon 2 factorial into 2 factorial into 2 factorial. How much is that? 7 factorial I know is 5040 into 7 factor into 8. That is 7 factorial. Into 8 upon 2 into 2 into 2. So this all gets cancelled with this 8. And we're left with 5040 ways in which the letters from the word calculus can be arranged. Now, when you go in for more complications, you will have 2-letter word, 3-letter word, all those restrictions will be there. But as far as you're concerned, you just need to understand and need to know this much. The next formula is when each of these n things may be repeated once, twice, up to r times, then a number of ways of arranging these n things taken r at a time, each time being repeated n times, each thing being repeated n times is given by n raised to r. Okay. This you also need to know because you can get theory questions on it. Okay. So try to understand it as far as possible. So you are taking n things and they may be repeated 1 time, 2 time, up to n times, up to r times. Then what will the formula be for each thing being repeated r times will be, and n will be given by n raised to r. Okay. Now, if for a particular thing, the answer may be yes or no. Okay. Only answers may be in yes or no. In that case, the total number of ways in which to deal with all this is given by 2 raised to n minus 1. Okay. When we solve the sums, you will be able to understand very well. Yes. Any doubts up till now? Yes, Asha. No, Saima, you have to just practice. See, Parveen has written, she has understood very well. Okay. You just don't have to worry. वन इज सेइंग आज जितना ही कर लो बस हो गया, निशी बोल रही है. No, Simon, everything is yes. You should be able to do it. Don't worry, Sakshi. We'll be taking some word problems in both permutation and combination once the chapter is over. And even like after some days, so that by that time you will also have practiced a lot. And then one of the days in between, whenever I have lectures with you, we will take 1 or 2 questions per day. So that way all your doubts will get cleared. Okay. See, when each of the n things may be dealt with in either of the 2 ways, okay, either of the 2 ways, that is, it may be taken or left, then the total number of ways of doing things will be 2 raised to n minus 1. Now let us see this question. An examination paper with 10 questions consists of 6 questions in algebra and 4 questions in geometry. At least 1 question from each section has to be attempted. In how many ways can this be done? Okay. So now take a question like the first question in algebra comes up. What are the possibilities? Either I solve it or I don't solve it. Okay. There are only these 2 options. And that is why I'm using this formula. Okay. 2 raised to n minus 1. So number of ways in which it can be done is now 2 raised to 6 in algebra and 2 raised to 4 in geometry. So this will be what? 2 raised to 6 minus 1 into 2 raised to 4 minus 1. So just using this formula, if you read this formula, understand this formula, then now nobody can stop you. Okay, all you had to do here was put in the formula and get the result. Okay, so you could do that on your own also. Okay, fourth is when out of n things, n1 are exactly alike, n2 are exactly alike, n3 are exactly alike, then and n is such that n is equal to n1 plus n2 up to n, then the number of ways in which the groups can be formed will be n1 plus 1 into n2 plus 1 into n3 plus 1 and so on minus 1. The combination of selecting R things from a set having n objects and R2 things from set having n2 objects, when the combination of R1 things, R2 things are independent, is given by this. Okay. Okay, let me just show you the sum. I understand you are tired and uh, it is a difficult topic in the sense you have to pay attention a lot. Now, I'll just show you the logic for this question and then we can stop for today. Don't worry. We will be doing the remaining questions also. There are 7 men and 3 ladies. Okay, 7 men, 3 ladies. Find the number of ways in which a committee of 6 can be found of them if the committee is to include at least 2 ladies. Okay, so option 1 will be what? I have at least 2 ladies. What is the size of the committee? 6. So if I have 2 ladies, how many men will I have? 4, right? And so what will be the solution? Out of 7 men, I have to take 4. So 7C4 into 3C2. Okay, find this. 7C4 because out of the 7, I have to take 4. And ladies, out of the 3 ladies, I have to take this thing. Second option is I increase the number of ladies to 3. At least 2 ladies, so I can have 3. And out of 7, I have 5. No, I can't have 5, right? Because I only need 6. So, 4 plus 2 is 6, which is the 6. So, 3, so it will be 3. So, out of 7, I have to select 3. 7, 3C into 3C3. Is there any other option? No, there is no other option. So, I only have to solve this 7C4 into 3C2 up and 7-3C into 3C3. Okay. So 7C4 is how much? 7 factorial upon 4 factorial into 3 factorial into 3 factorial upon 2 factorial into 1 factorial, which is equal to this 3 factorial will get cancelled, which is equal to 7 factorial. I know is 5040 and 4 factorial is 24 and this is 2. So how much is this? 5040 divided by 24 divided by 2, which is equal to 105. Okay. And 73C. Now you know that, see, this is what, if you know the formula, you know 7C3 will be equal to 7C4 because NCR is equal to NCN minus R. Okay, so these are complementary 73C and 734. So this will be 7 factorial upon 4 factorial into 3 factorial and NCN is always equal to 1. So this is equal to 7 into 6 into 5 upon 6 because 4 factorial gets cancelled. Okay, 4 factorial into 4 factorial. So I have This 6 cancels with this 4 factorial cancels with this. So answer is 35. So what is the total? 105 plus 35, which is equal to 120. Is that clear? Understood? Very simple. I always feel that if I write it like this, my understanding increases, and then I'm able to make sure that I have explored all the options. Otherwise, what happens is there are 5 options and I go up to fourth, but my answer does not match with that MCQ. Okay, that is the a little disadvantage in MCQ, that even the examiner can't give you any marks because you've done 10 steps correctly but missed out on the last 2 steps. Okay. Yes, Janvi, very good. Ruhani. Okay. Yes. Let us stop here for today. I understand you're tired. So don't worry. Let us meet in the next class and do certain remaining sums from here. Let us also go ahead and do a new chapter also. Okay. Vinu?